Welcome, Jessica.
Thank you. So I am also from MIT. I, like Saif, am a MIT-X digital learning scientist. I work on a number of different courses, but today I really just want to focus on the development of a single course and sort of take you through, talk you through that experience, how this course has gone from a sort of a very standard pen and paper in a classroom class to a MOOC, and then developed past sort of that MOOC situation, that MOOC format into something a little bit different, but that takes components from all of these things. So this course that I'm going to talk to you about today, we like our numbers. It's 3086, Innovation and Commercialization. And the goal of this course is essentially just to teach students, not just to, it's a big goal here, to teach students the fundamental process of innovation. And the students certainly do some study of historical and sort of modern examples of innovation that they have the opportunity to analyze. But the real cornerstone of this class and the real goal of this class is to give students the opportunity to practice innovation on their own with their own ideas. And we want to create a classroom that's collaborative, that's project-based, that allows students to really participate in this process. So as I said, this course has a long history, and in various different versions, it's been taught for about 15 years, sometimes in the engineering school, sometimes it's been taught in the management school. And in the last 2 or 3 years, it's really taken on this significant online component. We've offered it 5 times, either as a MOOC or as sort of a hybrid residential educational experience course. So it started off its life as a residential online course in 2013 with as a very simple sort of flipped classroom. Our professor took his lectures, put them online, and decided to devote his time in the classroom, as I think a lot of us are talking about, to discussion, to interaction, to talking with the students about their ideas and their developments. And then we decided to take what we had, the information that we had, and the lectures that we had, and turn this into a MOOC. So we started with some MOOC development, put the course online in 2014, and then after this course was offered on edX, we decided to incorporate all of these MOOC tools that we had into our residential course. So in 2014, we did that incorporation. And what we learned was we certainly liked some of the outcomes of incorporating the MOOC tools with the class, but that we actually felt we needed to do more, that we needed to have more development to really accomplish what we wanted to accomplish in the residential classroom. So in 2015, we've added some additional functionality, and I'm going to talk to you about that over the course of this talk. But I sort of wanted to take you through these developmental steps a little bit more closely. Our flipped classroom, our first flipped classroom, is really what got all of this started. And although we now had our students learning, the lecture sort of material via screencast, and we'd opened up time for discussion, many of the course components remained essentially unchanged. The students were still writing papers and doing the same assignments that they were doing in the classroom when it was sort of in a more traditional fashion. And I think that both the professors and the students enjoyed having, more time for discussion, less time spent learning facts. And so we decided, generally, we felt successful, and that we were going to take this and start to develop a MOOC from this course material. So, I have worked on a number of different MOOCs in the material science and material science and engineering department. And whenever you give a MOOC, I'm sure many of you know, assessment is always an enormous challenge. And assessment is an enormous challenge in engineering courses. And I will say assessment here is a particularly large challenge in a course where there's a lot of open-ended material. So one of the things we worked a lot, very, very carefully on was how can we develop some exercises that interacted and worked well with this platform that allowed us to do some online assessment that we felt was meaningful in this environment. So I just want to show you hopefully, I want to show you one example here. And here, essentially, we're asking students to consider a single innovation. We're asking them to look at something very simple, just the technology of a pen. And we give them this big matrix, and we ask them, and I don't think you can read the the headings, and I apologize for that, but we ask them to consider what the most important things they think are for various different functionalities of a pen. What determines a pen's durability? What's the most important thing there? What determines its ergonomics? What determines its lifetime? And we ask them to fill in this large matrix, consider what they think is most important, and then they press a check button. But we're not asking them to develop or to provide exactly the same answers that we give. We understand that there are a lot of different ways of looking at this problem. So we check and make sure that they have, depending upon the answer, maybe 50 or 70% of the answers in accordance with us. But really what we want them to do is we want them to go in, we want them to look, we have some interactive solutions for them, and they can go in, they can take a look and see how we answered the questions, how this differed from what they did, and they can decide if they've made, good choices or if there are better ones out there that they could have made. So after our first MOOC, we decided to bring this into the residential classroom in full force. And we decided to bring the MOOC tools into the residential classroom in full force. And so for this offering of this course, basically we had a theory where we're going to let computers do the things that computers do best. Give online videos, put some online exercises. And this is going to, as we all hope, I think, in these hybrid methodologies, free up our faculty to do what faculty really do best. So this included continuing these weekly discussion sections with the faculty. And another really important course component that we added some one-on-one mentoring sessions with the faculty that I think happened about 3 times this semester. And so because these projects were so critical to sort of the student experience in this course, providing them with one-on-one time to talk to the faculty, to develop their ideas, to work on their ideas, was really a really critical step for the faculty. But we still felt at this point that we sort of had these kind of discrete components. We had online parts, we had faculty parts, but we really wanted to bring everything together. We wanted these things, we wanted to make sure that these things were working together as well as they could to give the students really the best course experience we could give them. So what did we learn from this sort of first attempt to integrate the MOOC into our classroom? And what we found, what we determined was we thought that the best improvements we could make to this class would come from facilitating additional interaction, meaningful interaction with the students and the faculty, and meaningful student-student interaction that will allow our students to really collaborate together. So our faculty decided to focus their development on developing some better online project tools for their residential students that would allow the students to keep good records of their research, that would improve the collaborative environment, and that would really give the faculty greater insight into the students' thought processes as they were developing their innovation process, or their innovation projects. One of the faculty members on this course said to me, we sort of, in the old days, back at the beginning of time, it was all, lecturer lectures to students, and it's this one-way process. And now we've sort of moved away from that model, and we're starting to have discussions, and we're having interaction, and we're having back and forth kind of interactions, and that is wonderful and good and what we need to see in more classrooms these days. But he said one thing that's really missing, he felt, was the student to faculty interaction, this interaction in this other direction where the students are telling the faculty things and they're using that information to inform the work that they do with the students, the feedback they give their students, and the just generally the mentoring that they're able to provide. So really we're trying to enable both this communication and also the students really having their ability to tell us more. So we introduced some new project development software in our third iteration here of this course. And I don't want to talk too very closely about sort of the theories that go into what our faculty are trying to teach, but I have to give sort of a basic overview to you guys. And basically, their thought is that any innovation can be broken down into three basic categories. Any innovation will always have technology components, always have market components, and will always have implementation components. And the students need to speak to all of these things. But as you look into any one of these different categories, you start to see all sorts of very, very small bits and pieces that are coming out as important to the student's innovation or anyone's innovation. So if I take a very simple example, if I'm just looking at eyeglasses and I want to think about what makes up an eyeglass innovation, well, if I look at technology, I can think of something, a lot of different components that make up the technology of eyeglasses. Maybe I want to think about lens technology. And then as I look down, I can think about all sorts of things that are just related to lens technology. So perhaps the coatings you put on your lenses. And I can get more specific and think about anti-reflective coatings, and more specific and think about specific anti-reflective coatings. And the point of this is not to make you think too terribly closely about the technology of your glasses here, but to give you the idea that these students who are developing these projects are having to look at really a huge number of different components that make up their innovations in a very in-depth way, and also the interaction between those different components. And we want to facilitate them undertaking this process. So our project software, our faculty's project software really aims to do two things. One, we want to give the students the ability to identify all of these very important components that they need to understand in order to move their innovations forward. And for each component, what's really essential is that the students perform a lot of good in-depth research to understand what's going on, what they need to know to improve upon their technologies or market or implementation, and explain how that research informs the path forward. And they need to understand this for themselves, and they need to be able to communicate this with their classmates that they're working with on their projects, and they especially need to be able to communicate this with the faculty who are helping them and are helping to mentor their projects along. So now we have this second version of the course. We're using these MOOC materials, but we're also using some software now that we've developed specifically for our residential students. And we believe that the introduction of these sorts of tools have really improved the outcomes that we're seeing in the class. So we try to identify some project metrics that would allow us to sort of compare the outcomes between the two different versions of the class to see how well we were doing. And so there are two basic categories of metric, if you will, that we looked at. First of all, we wanted to know how well researched these projects were. And as a stand-in for how well researched these projects are, we looked at how well referenced these projects were. How many different references were these students using to understand and develop their ideas? And the other thing that we decided to look at, we decided to develop a set of project metrics, a set of project goals that we had for the students. For each of two versions of the project. The idea here being, again, another sort of foundational idea in this course is that innovation is always iterative. You don't come out and have your solution first time through. The goal is to teach the students that they learn, they make attempts, and what they learn informs their next approach. And so we look at two different assignments which consist of two different iterations of the student project, and we look for some metrics. I don't want to talk to you about the details of all of the 23 different metrics that we provided, but I did want to give you an example of a few that we used. The first related to intellectual property. Did the students understand the patents or the copyrights or the trademarks or anything relating to intellectual property that pertained directly to their innovative ideas? A second metric we used when we were evaluating student projects was, do the students understand the industry structure that they are proposing that their innovation will be working within? Do they understand something about that structure? And the third question we asked about the student projects was, did they understand enough about the market for their innovation that they had identified both who might purchase this product and why they might purchase this product? So again, we came up with a list of different metrics, all of them sort of similar to what I've put out here. And we went through the project assignments, both from sort of the pre-software and post-software perspectives, and we added things up to see how we're doing. And in general, we were quite pleased with what we were seeing. When we looked at the number of technology references that the students were providing to us, they were increasing dramatically. For the first assignment, students were only looking at a single reference and were only researching a single reference with their innovation. When we added some better record-keeping abilities for them, this turned into over 11 references, a real substantial change there. And we see the same thing in our second assignment, very similar gains. Now, I do want to point out to you that in 2014, all of the students had to do their projects individually because we couldn't find a particularly good way of getting the student collaboration going. With more project software, we found that collaboration was easier, and so we allowed students to choose to work in larger groups if they wanted, so we had groups of 1 to 3 students at a time. Perhaps if you prefer, a better metric might be the number of references each of the students in the class was providing, as if a project has 2 students, there may be just more boots on the ground there that we could have. But even from that perspective, the number of references each student was providing went from 1 to 6 when we introduced better record-keeping software. It went from 2 to almost 10 for their second iteration of their projects. And when we looked at project metrics, we saw similar sorts of gains. With our first assignment, we found that they were, on average, meeting less than, or demonstrating less than 3 of these project goals that we had for them. And as we added some new technology for them, that went up to over 5. And again, we see a similar gain with our second assignment.
These are project metrics per student?
These aren't project metrics per student because I don't think we can really talk about project metrics per student in that sort of way.
It would be that you only have more students without so you have more projects just because.
Sorry? It's per project. Per project. Per student project. And the mean number of technology references per student project.
That's 2 months.
Yeah, per project. Per individual student project. Or per group student project. So, our conclusion is that we really do think that the addition of these tools are helping us increase the scope, the depth, and the quality of the student projects. And because, these student projects are so fundamental to this course, this is really exciting for us to see. Sort of next steps, we talk, our faculty talks so much about the importance of iteration. We want to, encompass that or embrace that in what we do. We want to go forward. And I think our steps forward, including, trying to further enhance student-student communication and further improve instructor-student feedback, because we found that we were getting, some enormous gains when we were able to do that. So I thank you guys for your attention. Are there any questions?